Hi, welcome to my oral communication presentation on significant figures. So what are significant figures? Significant figures are the digits in a number that carry the actual value of the measurements that you've taken or the calculation that you've done. So in these instances, like 105,000 and 0.00045, the 105 and the 45 are significant, while the other zeros there are really just there for scale. So what problem does the system of significant figures have? It allows us to communicate our accuracy in our measurements just by writing them down. I think you've seen sometimes like plus or minus zero point 0.1 or plus or minus zero point 0.2, but using a standard set of significant figures lets us do that without any of that unnecessary extra steps. So how do you tell how many significant figures a written number has? Well, we know that all non-zero numbers 1 to 9 are always significant, and most of the rules come from which zeros are significant. So we know that zeros come before the zeros that zeros that come before the first non-zero digit are not significant. And that's why in many numbers we don't write them down. For instance, very few people would write 125.12 as 00125.12 because those zeros at the beginning aren't communicating any information. Likewise with 0.00054, the first four zeros before them, before the 54, are just communicating scale, so those are not significant. However, zeros after the decimal and after a non-zero digit are significant. So for instance, 0.000750, the first four zeros are communicating scale. That 7500 is very small. But the last two zeros are communicating that it's very close to 7500. It's not 751 or 7599. So we know that the 7, the 5, and the two zeros at the end are significant. So there's four significant figures. Now, lastly, if there's a decimal point and the number is greater than 1, all zeros after the first non-zero digit are significant, otherwise they're not. So this is a formal, complicated way of basically saying that if there are significant figures in the end, or if there are significant figures in the beginning and the end and there are zeros between them, those zeros become significant. So let's take the example of 100.00 and 100 without any decimal point, or zeros afterwards. Well, 100 has only one significant figure, the first one. Those zeros afterwards, they're not significant because there's no decimal point, they're just after the number. So that number could theoretically be like 105 or 97, right? But with 100.00, we know that that number is accurate to 100 to two decimal places, which means it's definitely not 97 or 105, because we know that because the tenths and the hundredths place are significant, the ones and the tenths also have to be. So now the most common way that you're going to be using um, significant figures in the lab is with measurements. And so the general rule with measurements is you can get measurements as precise as the tool you're measuring with plus one. So what that means is if you have something like this bad measuring test tube, and each of those lines is a millimeter, you know the ones digit certainly. Let's say it's in between the 4 and the 5. You know that it's at least 4. But, there's still some information there because you can tell the distance between the 4 and the 5. So let's say that you thought it was around 3/10 of the way up. Well, now you can say 4.3, and that gives you two significant figures, even though there's only markings in the one slot. Now, similarly with a centimeter ruler, let's say it's in a similar spot. It's above the 4, but below the 5. Well, now because we have these tenths markings, we also know that it's above the 4.3 and below the 4.4. And if it was around halfway up, we could say, oh, we can say with confidence it is 4.35. Three significant figures, one from the ones that's on the ruler, one from the tenths that's also on the ruler, and one for the hundredths, which is estimated in between by you. So that's how you're going to be taking measurements with your tools and figuring out the significant figures that you write down in your labs. And lastly, you might be thinking, well, what about stuff like the people in my family, right? Like you can really only have two, three, or four people in your family, or five or six if you have a big family, unless there's like a horror movie going on or something, and you have two and a half people. They kind of snap to one of the integers. Well, counting numbers like those you can think of as having an infinite number of significant figures. So they have as many significant figures as they need. So, thank you very much. I really appreciate you listening to me. I hope that you use significant figures well in your scientific career, and I hope you have a wonderful day.